Hello students, welcome to the another session, and in this session we will be discussing the concepts related to lines and planes. So what exactly the equation of the line and equation of the plane required, how we are going to find out, we'll be discussing. See, first of all, general form of the plane. What is the general form of a plane? This will be of the form ax plus by plus cz plus d is equal to 0, where a, b, c, d are four unknowns, but it will be reduced to three unknowns. This b by dy plus c by dz plus 1 is equal to 0. So effectively three unknowns are there. So required three conditions to find the plane equation. Okay. So basically AI is a point xi, yi, zi. Equation of the plane passing through these 3 points is a depth of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Or if I want to find the plane, okay, passing through x1, y1, z1, containing the lines L1 and L2, whose DRs are A1, B1, C1, A2, B2, C2. This equation will be x minus x1, y minus y1, z minus z1, A1, B1, C1, A2, B2, C2 is equal to 0. Similarly, if I want to find a plane in the different forms, means a plane which is a plane which is p units away from the origin. So this is the plane equation I need. R is in here. So from here to here, this is p units. So just you find out the DCs of this normal L comma M comma N, then the plane equation will be Lx plus My plus Nz is equal to P. Here simple thing is L square plus M square plus N square should be equal to 1. Now this is the x-axis, y-axis, z-axis. A plane is moving like this, where x-intercept is A units, y-intercept is B units, z-intercept is C units. The plane equation is x by A plus y by B plus z by C is equal to 1. And if this is one plane, this is one plane, and this is another plane, so the intersection of two planes is always a line. Always a line. Okay. So how this line of intersection need to be find out, etc. I'll tell you. Okay. So generally, what is the thing to find the plane equation? You require three conditions. Okay. Now, what about the line? What about the line? equation of the line passing through x1, y1, z1, having the directional cosines of this one is x minus x1 by L, y minus y1 by m is equal z minus z1 is equal to n. Particularly, this portion will be taken, means when this element are the directional cosines, ABC are direction ratios. Both are same, but I prefer taking this one, particularly when I have this is x1, y1, z1. I need to find a point on this one, which is r units away from this. So automatically, I will take here r. So x1 plus LR, y1 plus MR, Z1 plus NR is a point which is R units away from X1, Y1, Z1 on the line will be given. And another one is to find the line when DCs, DRs are there fine, but I want to write this is X1, Y1, Z1, here X2, Y2, Z2. How to write the 2 point form? 2 point form will be simple x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Why? Here simply x2 minus x1, y2 minus y1, z2 minus z1. These are the drs of the given line only. Okay? Look at here. Any point on the line passing through x1, y1, z1 having the DCs, the directional cosines or element of the form, then x1 plus LR, y1 plus MR and z1 plus NR, where R is a point parameter. So this is a point which is R units away from x1, y1, z1. Okay, and this is also parametric form of the line. That's okay. X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3 are area. This one is there. Collinear if and only if this determinant is equal to 0. This determinant is equal to 0. Why this is gives us the area of the triangle. See, particularly in if these are the three vertices are given, if someone is asking about area of this triangle, simply you find out this is A bar, this is B bar. You can go ahead with half of A bar cross B bar to find the area. If this value is equal 0, those points are collinear. Okay. Now, angle between two lines, angle between two planes, angle between two lines, angle between two planes. This is x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1. This is a line x minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. What is the angle between them? So these drs of this line are a1, b1, c1. Drs of this line is a2, b2, c2. So simply cos theta is equal to sigma a1, a2 by root over sigma a1 square into root over sigma a2 square. If a1 a2 plus b1 b2 plus c1 c2 is equal to 0, they are mutually perpendicular. They are mutually perpendicular. Okay, and if I want to find the angle between two planes like a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2. So this is one plane, okay, and another one is this plane. So in this case, normals of drs of this normal is A1, B1, C1. Drs of this normal is A2, B2, C2. Angle between the planes denoted by angle between their normals only. So again, cos theta is equal to sigma A1 A2 by root over sigma A1 square into root over sigma A2 square. So if sigma A1 A2 is equal to 0, the two planes are mutually perpendicular. The two planes are mutually perpendicular. Okay. And now if I want to find a angle between a plane, if I want to find a angle between plane and a line. This is the plane and this is the line. So this plane is A1x plus B1y plus C1z is equal to D1. This is the line x minus x1 by A2 is equal to y minus y2 by B2 is equal to z minus z2 by C2. So drs of the normal of the plane are A1, B1, C1. These drs are A2. So this plane, this is perpendicular to the plane. So if the angle between line and plane is theta, so this angle is going to be 90 minus theta. So cos 90 minus theta. Cos 90 minus theta is sin theta. Is equal to angle between these two lines whose drs are A1, B1, C1, A2, B2, C2. So again you will get sigma A1, A2 by root over sigma A1 square into root over sigma A2 square. So the angle between acute angle between line and the plane, instead of cos, we will be getting sin theta. Now, another point is a line is in the plane. So how can we say a line is in the plane? If this is the plane and line is part of the plane means each and every point. That means this x1, y1, z1 should be here. So this x1, y1, z1 should be here. So this point plane need to satisfy that point. And also drs of the line is L comma M comma N. Drs of the normal of the plane is A, B, C. So these two need to be mutually perpendicular. AL plus BM plus CN is equal to 0. And this is the plane and some line is said to be parallel to the plane. That means dr dot product of drs of the line and the normal of the plane should be mutually perpendicular. This is L. There are the little typo errors of the place. And a line is perpendicular to the plane means line should be parallel to the normal of the plane. Okay. So what I can write here is simple. What I'll write is if line is perpendicular to normal, then line is parallel to plane. Line is parallel to normal, line is perpendicular to, okay. So this is what. If angle between line and normal is theta, angle between line and plane will be 90 minus theta. Now, two lines generally they'll give and they'll say they are coplanar or they are intersecting also. Either they have the same dr or parallel coplanar, otherwise their intersecting is also coplanar. So this point is this one. Okay. Equation of the plane containing this one and parallel to this line is containing this one. Any plane containing. Simply you write x minus x1 in the first, y minus y1, z minus z1 here. L1 M1 N1, L1 M1 N1 here. And the second part thing L2 M2 N2. This value is equal to 0. Now there is a possibility of writing line. This is one line, this is one line. So in 2D it is little difficult to express, but these lines are neither parallel nor intersecting. Neither parallel nor intersecting is possible. If the lines are neither parallel nor intersecting, such lines are known as the skew lines. Means here this equation is in the vectorial form. If you write R bar is equal to A bar plus SB bar, R bar is equal to C bar plus TD bar. The shortest distance is equal to box of A bar minus C bar, B bar, D bar by modulus of B bar cross D bar. So if you write, for example, the shortest distance between these two lines, let us assume the shortest distance between these two lines if I want to take. Which two? These two. So what is the shortest distance? It's simply that of x1 minus x2, y1 minus y2, z1 minus z2, L1, M1, N1, L2, M2, N2 divided with I, J, K, L1, M1, N1, L2, M2, and whole modulus because you require the positive one. This is the shortest distance. This is the shortest distance. Next point is the condition that the line coplanar. The next point is what they're talking about. This one and this. You need to understand what is this mean. They have given two planes. When two planes are given equated to zero, that means this is one plane and this is another plane. So this plane has to be zero and this plane has to be zero. So the common point is going to be common intersection will be line of intersection. Line of intersection. You know how to find this line of intersection. This DRs will be cross product of A1, B1, C1, A2, B2, C2. And you randomly choose a point and that one you are going to get the answer. Now, these two are coplanar. What you do, simply you substitute x1, y1, z1 in the first plane, a1 x1 plus by y1 plus c1 z1 plus d1 by a1 l plus b1 1 this one and substitute in the second one. You are going to get. Two lines are said to be skew lines if there exists no plane containing them. Okay, the shortest distance formula. Here again, we have given the shortest distance formula. The perpendicular distance from Px1, y1, z1 to the plane ax plus by plus cz plus d is equal to 0 is ax1 plus by1 plus cz1 plus d by root over a square plus b square plus c square. Similarly, perpendicular distance from the origin to this one, perpendicular distance from origin to this one is mod d by root over sigma a square. Okay. Angle bisector of the plane. If this is a plane and you have a plane like this, another plane is like this. So you have two planes, angle bisector of this. So angular bisector of plane means maybe this plane will be like this. So how is this plane? This plane is any point perpendicular distance from this point to this plane, and this plane should be same. It is a property similar to two-dimensional geometry. Angular bisector, acute angle bisector, this condition, but this much of depth is not required. Okay, only basic definition is more than enough to solve. And angle between two planes is this one already given. A1 A2 plus B1 B2 plus C1 C2 by root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square. So what is the angle bisector? Angle bisector is set of the points which are equidistant from the given two planes. Next point is foot of the perpendicular and image. Okay. So this is a plane is AX plus BY plus ZZ plus D is equal to 0. If here the point is x1, y1, z1, drop the perpendicular. This is the foot of the perpendicular. If you extend this one, this is called the image. Okay. So, if you remove this portion, without this, you look at it is the two-dimensional geometry. Without this, it is the two-dimensional geometry. So, same formula you can remember and recollect and solve the things. Okay. So simple thing is your DRs of this line will be A, B, C. So what we'll do, any point is R unit, this will be 2R. If from here to here R units, from here to here it will be 2R units. That's why here minus 2 comes extra. Equation of the plane passing through the intersection of any two planes. Okay. So you have a plane like this. Okay. And you have a plane like this. This is phi 1. This is phi 2. Any plane through this intersection, if I want to write, that can be written as phi 1 plus lambda phi 2. So this will be very much needed in your 3D matrices and determinants. System of equation, three equations having the infinite many solutions. Pi 1 plus lambda pi 2 is equal to third one. So any plane through the intersection of two planes is this. Okay. Next one is, next point is, if this is the plane, this plane is dividing entire the region into two parts. So here A x1 y1 z1 and B x2 y2 z2. So this is pi is equal to 0. If both are same side of the plane, then pi A into pi B will be greater than 0. Now, if this plane is this side, here like this, here A is there, here B is there. In which ratio this plane is dividing AB? So simply this distance, it is M is intersection. So I need only AM by MB, which is equal to you drop the perpendicular here and you drop the perpendicular. This is simply P1 is to P2. So P1 by P2. But only thing is P1 is here, if it is positive, will be this value will be negative. So P1 is equal to simply pi A. If I take this positive value, P2 is equal to pi b modulus. So if points are either side, minus sign will be there. So that's why we'll get pi a by pi b. You'll get minus of pi a by pi b. If the ratio is positive, the plane is internally dividing. The ratio is negative. Plane is dividing externally. If A and B are same side of the thing, pi A, pi B is pi positive. If B lying opposite side, pi A, pi B will be negative. Okay? So with this one, the concept, basic concepts are covered and we'll continue solving the problems.